Yeah, very good morning to one and all. Today, let us discuss about hypocycloid. Hypocycloid. Just go through the definition of hypocycloid. It is a curve traced out by a point on the circumference of generating, or it can also be called as rolling circle when it rolls inside the directing circle without slipping. That means in case of epicycloid, we considered that it is also we have traced out a point on the circumference of rolling or generating circle when it is assumed to be rolling above the directing circle. But whereas here in this case, here also we are going to trace out a point on the circumference of rolling or generating circle whenever it is assumed to be rolling inside the directing circle. That means first of all you should be clear with the definition, because every time in the exam directly it will not be asked to draw the epi or hypocycloid. Sometimes question may be asked with reference to the definition. That's why with reference to the definition itself we have taken down a question. Please go through the question. A generating or rolling circle of diameter 50 mm rolls inside the directing circle of diameter 130 mm. Now it is asked to draw the curve traced out by a point on the circumference of generating circle for one revolution, and also draw the tangent and normal about any point on it. Here I have underlined the word inside, because inside refers that it is clear that it is nothing but hypocycloid. That's why I have underlined the term, and we have come across two circles. One is directing circle and the other one is rolling circle. As we discussed earlier, directing circle is nothing but what? The circle which remains stationary, that means standing still. And rolling or generating circle is nothing but what? A circle which tends to roll about a surface is called rolling or generating circle. Here this inside the directing circle, the generating circle is going to be rolled inside the directing circle. Whenever it rolls inside the directing circle, if we trace out a point on the circumference of the rolling circle, the curve obtained will be called as hypocycloid. Now let us see how to draw this hypocycloid. It is also similar to that of epicycloid itself, but there will be a slight difference in it. First, let us take down the diameters of both this one, generating circle and rolling circle. Here directing circle's diameter is given as 50 mm, whereas rolling circle's diameter is given as, directing circle's diameter is given as 130 mm. That means the radius of the rolling or generating circle will be of 25 mm, d by 2, 50 by 2, and the radius of directing circle will be of 65 mm. First we have to note down, let us assume smaller as radius of rolling or generating circle and capital R as radius of directing circle. And at first we have to find out the angle. What is the angular displacement covered by the rolling or generating circle? So as to find out the angle, likewise you followed in the epicycloid. Here also we have to consider theta equals to small r by capital R into 360 degrees. Small r by capital R into 360 degrees. And here small r is nothing but what? Radius of the generating circle or the rolling circle. According to the question, radius is given as, diameter is given as 50 mm. Therefore, its radius is 25 mm. And capital R is given as 65 mm. That means its diameter is given as 130 mm. Its radius will be of 65 mm. And we know the total angle in the circle is 360 degrees. If it is multiplied by 360 degrees, we get 138.46 degrees approximately. That means approximately we can say that 139 degrees. Now if it is divided by 12, because Why we are going to divide it into 12? Because we are going to divide the generating circle into 12 equal parts. That's why this angle made for one revolution theta, which is found as theta, which equals to 138.46 degrees, is also to be divided into 12 equal parts. If you divide the generating circle into 8 equal parts, you have to divide this total angle theta into 8 equal parts. That means always we have to divide the total angle made by one revolution into number of equal parts we have divided the circle. That means here we get something 11.53 degrees. 11.53 degrees. Now let us start to draw the hypocycloid. Now let us start drawing this hypocycloid. At first, what we have to do is, with compass, first you mark the point which is assumed to be center of the directing circle, which is represented as O1. And here the diameter of the directing circle is given as 130 mm, therefore its radius will be of 65 mm. With radius 65 mm, I have drawn a circle. This circle must be thick. Okay, whatever it may be, some errors will be there. Now choose any one of the points on this circle. I have chosen this point. From there, join this point. Now here the diameter of the direct rolling or generating circle is given as 50 mm. Therefore, its radius will be of 25 mm. With radius 25 mm. Just mark the point. Now, with this point as center and with radius 25 mm, draw the generating circle or rolling circle inside this directing circle. This must also be thick. In case of epicycloid, we have drawn the circle outside the directing circle. Now, using protractor or compass, divide the circle into some equal number of parts. Generally, we will divide the circle into 12 equal parts. All these lines must be thin. And using the compass, let's measure this radius. This radius, the same point as center, and with the radius of the rolling or generating circle, I have cut this circle. You can also do the same using this protractor. For each 30 degrees, if you mark the point, the circle will be divided into 12 equal parts. But this will be better because you can avoid the errors if you divide using the compass. Let us assume this point as O, and let us join the opposite points passing through this point O. And while let's divide the circle into 12 equal parts. We have divided. Now the point where it is in contact is assumed to be the 12th point. From there I have marked the series of points as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That means, as we know that there are infinite number of points around the circumference of the circle, as it is not possible to represent all the points, just I have represented the 12 points which are at equidistant. Now already we have found out the value of theta. That means whenever this point 12 comes into contact with this circle, whenever this point 12 comes into contact with this circle, we can say that one revolution is completed. So as to complete one revolution, we have to find out the angular displacement made by this rolling or generating circle. That means we have to find out the value of theta, and we have found out the value of theta as theta equals to small r by capital R into 360 degrees. Likewise, what we have done in epicycloid. And here the small r is the radius of the generating circle or rolling circle, and capital R is the radius of directing circle, and that must be multiplied by 360 degrees because the total angle in the circle is 360 degrees. And we got that 138.46 degrees as the angular displacement covered by the generating circle inside the when it rolls inside the directing circle. And as we have divided this circle into 12 equal parts, I also divided this 138.46 degrees into 12 equal parts. I got 11.56 degrees. Here you can follow two approaches. Directly you can measure the angle 138.46 degrees, and afterwards you can divide it into 12 equal parts. But that will be somewhat, you can come across many errors if you take the total angle. That's why it is better to start with 11.5 degrees. That means with protractor, measure 11.5 degrees on this. With protractor, place the protractor on this and measure 11.5 degrees. Exactly, it is not possible to locate the 11.5 degrees. That means we can locate it in between 11 and 12. And join this to O1 and let it be the first point. Instead of 1, I am representing it as 1 dash. Now let us generate remaining 11 more points with the same distance from 12 to 1 dash. Measure from 12 to 1 dash, distance 12 to 1 dash. Measure the distance 12 to 1 dash, and from 1 dash mark the successive points. Up to 12 points. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. This is 2 dash, 3 dash, 4 dash, 5 dash, 6, pencil is giving trouble. This is 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, and this will be the 12 dash. Now what you have to do is you have to join all these points. One dash, 2 dash, 3 dash, 2, 1. Here I am drawing somewhat thick lines because that will be visible for you. To actually have to draw all these lines as thin lines. Now if you measure the total angle, you will get 138.46 degrees. Now the bottom side circular profile is unnecessary for us, that's why, so as to avoid the, so as to use the space effectively on the paper, I am erasing this one. And though if you not erase also, it doesn't problem, it is not at all a problem. No. Once again, do the same what you have done in case of epicycloid. Now with O1 as center, O1 is the midpoint or center of the directing circle. With O1 as center and with radius O1 O and with radius O1 O, mark the midpoint. Just follow the same procedure what you have followed in case of epicycloid, but only the difference is there we have drawn the circle outside or above the directing circle, but whereas here in this case we are drawing the circle inside the directing circle. Now mark these positions as wherever this curve gets intersects. Wherever this curve gets intersects, this is the point O. Wherever this curve gets intersects about these lines O1, 1 dash, O2, O1, 2 dash, O1, 3 dash, there just mark the points as O1, O2, O3, O4. That means here we are marking the position of the center whenever the generating circle tends to roll inside the directing circle. O6, O7, O8, 9, O11 and O12. Now mark the position of remaining points also. Likewise, mark the position of remaining points also, what you have done in case of epicycloid. Now with radius O2, as I am measuring these points, with radius O1, this O1 and 11, if you draw a curve, it passes through 11 and 1 dash, 11 and 1, and next O1 10. It passes through 10 and 2. This is the second line. 9, O1 9. It passes through 9 and 3, and with radius O1 8. It passes through 8 and 4, and with radius O1 7. It passes through 7 and 5. Last point 6 with radius O1 6. Draw these points. That means here I have located all the positions. I hope the video is also clear. Now what you have to do is, whenever this circle tends to rotate inside this directing circle, at first this point 1 comes into contact with 1 dash on the directing circle. The point 1 on the rolling circle comes into contact with the 1 dash, point 1 dash on the directing circle. This O moves from O to O1. Similarly, whenever this 2 comes into contact with 2 dash, and O moves from. Here also you should not cut the center. O4 as center, you have to cut the next line, not the center line. O5 as center, the next line. Similarly, O6 as center. This is what the line is. Next, O7 as center. Again ascending. First you have to descend, and after that you have to come in ascending order. O8 as center. The next line. O9 as center. The next line. That means here also you should not cut the center. O10 as center. The next one. And O11 as center. And if O12 as center, you will get the point 12 dash itself. Now let us mark all the points as P1, P2, P3. P1, P2, P3, P4, and this is what P5, P6, P7, P8, P9, P10 and P11. Now from 12 join all these points. Sorry, yellow. From 12 join all these points with free hand. You will get a curve which is called as hypocycloid. Now for the same hypocycloid, it is asked to draw the tangent and normal about any point. According to the question, you can draw tangent and normal about any point. That's why I have chosen a point on the curve which is named as M, and from M, with just what you have done in epicycloid, follow the same procedure. With M as center, and with the radius of the rolling circle, cut the center line. Now you have to cut the center line. With M as center and with the radius of the rolling circle, cut the center line. Now, once again, this compose is not near focus. Now, join this point to O1 and extend the same point onto the directrix. Onto the directing circle. Join this point to O1 and extend the same line to the directrix. Wherever it gets intersects on the directrix, let us name that point as P. Now from P, if you draw a line passing through point M, that will be the normal. And as we know that tangent and normal are always perpendicular to each other. Perpendicular in the sense what? The angle must be of 90 degrees. Just mark the point 90 degrees, and if you draw a line passing through the same point M, that will be the tangent. That will be the tangent. Always the tangent and normal will be perpendicular to each other. That means the angle made by the tangent and normal will be of 90 degrees. And at last, after this completion, you should not forget to give the dimensioning. Whatever the data given in the question is to be dimensioned. Here the diameter of the rolling circle is given as we know that these arrowheads must be in the ratio of 1:3. With ratio 1:3, by measuring with scale, mark these arrowheads. And here this diameter symbol is 5, and this diameter of this rolling circle is given as 50 mm. And as usual, the diameter of the directing circle is also given as 130 mm. Here it is not possible to give the dimensioning of the diameter. That's why just I am representing the directing circle. This is what the directing circle is now, with arrowhead, and I am giving the dimension. This type of line is called as leader line. Diameter 130. Here enter dimensions is also given. And what is this we have drawn is hypocycloid. Hypocycloid. It is a curve traced out by a point on the circumference of this rolling circle when it rolls inside the directing circle without slipping. That means here also we had started with the directing circle, and we have assumed a rolling circle which is rolling inside this directing circle, and for one complete revolution means if this point 12 comes into contact with this 12 dash point, we can say that one revolution is completed. For one complete revolution, we have traced out the point number 12. A curve is generated. This curve is called as hypocycloid. If this rolling circle is assumed to be rolling above the directing circle, it is called as, if you trace out a point on the circumference of the rolling circle, it is called as epicycloid. Whenever this rolling circle rolls inside the directing circle, if you trace out a point on its circumference, the curve generated will be called as hypocycloid. That is what you have to remember. That means with this we have completed the concept of cycloids. That here we have come across three types of cycloids. One is general cycloid, and the other one is epicycloid, and the third one is hypocycloid. I hope that everybody is following the video, and if you follow the video, you can answer in the examination. Okay, thank you.